Coffee farms are primarily located around the equator. Once harvested, coffee cherries undergo a traditional sun-drying process. Once appropriately dried, the cherry fruit is removed by hulling to reveal the coffee beans. The beans are then distributed to coffee processors and roasters worldwide. Within coffee processing, decaffeination of the bean is a common production step. The Swiss water method, patented in 1993, begins by filling a 2,500-liter preloading tank with 2,000 liters of water, 50 kilograms of cane sugar, and 10 kilograms of formic acid to make an extract solution. This extract solution is then passed through carbon absorption columns, which contain activated charcoal. The activated charcoal selectivity for caffeine is increased as it picks up molecules, including sugar, from the extract solution. Therefore, when the solution washes the coffee beans, the only substance absorbed by the extract solution is the caffeine molecule. The coffee beans are pre-cleaned to get rid of foreign matter and then added to the coffee columns in a continuous process. The beans are then soaked with water until they double in size to prepare for caffeine extraction.
Once all of the water is removed, the extract solution is pumped into the coffee columns. Raw coffee beans and the extract solution are mixed. Once the extract solution is pumped out, the bean column is sent to the dryer. The dryer works by evaporating the moisture in the coffee and removing it through an air exhaust stream. The extract solution that is enriched with caffeine is pumped out of the coffee columns and into the carbon absorption column. The column filters the solution. In this way, the extract solution is stripped of its caffeine content and may be reused for further coffee bean extraction. After 8 hours of filtering, the solution is once again caffeine-free and ready to be reused. The activated charcoal, now saturated with caffeine, moves to a carbon regeneration furnace where the caffeine is burned off and the geometry of carbon is recreated and reused to collect more caffeine. This whole process takes about 10 hours in total.
Our group then visited a local Jittery Joe's roaster to examine the roasting process. Before the batch roasting process begins, 75 pounds of coffee beans are weighed and poured into a hopper, which will lift the beans into a holding tank of the roaster. Once all the beans are in the holding tank, they will be released into the roaster, which is set at 433 degrees Fahrenheit. For the first 30 seconds of the process, a hatch between the hopper and the drum are left open for airflow so that chaff from the beans are stripped off and go into a waste barrel. The airflow waste removal process occurs periodically throughout the roasting to improve product quality. As the beans roast, a paddle stirrer within the roaster continuously mixes the beans to ensure even roasting. Small samples of the coffee beans are regularly obtained to check roast progress. Once the desired roast is obtained, the beans are removed by opening a hatch that empties them into an agitator. The agitator is a large open tank that stirs the roasted beans while a fan pulls the heat through holes on the bottom. Once the beans have cooled to room temperature, they are ready to be packaged. If ground, the beans are poured into the top of a burr mill. Beans poured into the top of the mill are quickly ground and dispensed into a can or bag. To can the beans, cans filled appropriately by weight are sealed with a one-way pressure valve. A plastic lid is placed over the sealant to prevent damage. From here, the coffee beans are now ready for distribution.
Coffee beans enter a dryer with a moisture content of 40% and exit with a moisture content of 12%. Then 75 pounds of beans enter a roaster and exit with a moisture content of 2%. The skin of the coffee beans in excess water exit the roaster, which brings its final weight to 63.5 pounds. Find the mass of the beans entering the dryer, the mass of the coffee skin collected in the waste container, and the total mass of water removed from the beans. By first looking at our material balance equation, we can remove the generation and accumulation terms, which gives us N equals out. Then by doing a coffee beans balance at the roaster, we can find the mass of coffee bean skin that exited into the waste container. The water balance at the roaster will tell us how much water was removed into the waste container during the roasting process. The coffee beans balance at the dryer will tell us our original mass of coffee beans that entered this process. Our water balance at the dryer will tell us how much moisture was removed during the drying process. Finally, by adding the masses of water removed from both the dryer and the roaster, we can find the total mass of water removed from the coffee beans. We can use the material balances of the entire system to check our masses and make sure that they're correct.